In this Packet Tracer physical mode activity, you have been tasked with configuring access control lists on a small company's network. ACLs are one of the simplest and most direct means of controlling Layer 3 traffic. After initial configuration is complete, the company has some specific traffic security requirements that you will be responsible for implementing. Build the network and configure basic device settings. Cable the network as shown in the topology. Cable and power on the devices. Okay, connect gigabit 00 on R1 to server A. Is this connection gigabit 000 on R1 to server A. Now gigabit 001 to fast Ethernet 5 on S1. Gigabit 001 on the router to fast Ethernet 5 on switch S1. Fast Ethernet 1 between S1 and S2. Fast Ethernet 1 on both sides. Fast Ethernet 1 on S1. Fast Ethernet 1 on S2. Now Fast Ethernet 5 on S2 to gigabit 001 on R2. Fast Ethernet 5 on S2, gigabit 001 on R2. On S1, Fast Ethernet 6 to PCA. On S1, Fast Ethernet 6 to PCA. This is PCA and use the Fast Ethernet interface. Fast Ethernet 18 on S2 to PCB. Fast Ethernet 18 on S2 to PCB. This is PCB Fast Ethernet interface. Okay, and power on the devices. Okay, on R1, the power button. Okay, S1 and S2 are connected to the power distribution device and they are power on. R2 power on. The server power on already, PCA power on, and PCB. Okay, and now use a console cable to connect a PC to each switch or router as you configure them. We recommend connecting PCA to R1 and PCB to R2. So use a console cable to connect from PCA RS232, PCA to R1 console. You have this connection from PCA to R1 using console. Another console cable from PCB port RS232 to router R2 console. Okay, very nice. And now configure basic settings for each router. Okay, I will use a notepad, okay, because these configurations will be applied on both routers and also be useful for switches. Okay, so assign a device name, okay, the host name, for example, for R1 according the addressing table R1. DNS, disable DNS lookup. no IP domain lookup, assign class as the privilege exec encrypted password, enable secret class, Cisco as the console password, and enable logging, line console 0 password, Cisco login, Cisco PTY password. You will enable logging later in this activity. Okay, so only the password. Line PTY 0 to 15, all lines, password Cisco. Okay, exit and encrypt the plain text passwords and create the banner. Okay, service password dash encryption banner message of the day. Unauthorized access is prohibited. Okay, and save the running configuration to the startup configuration. Okay, and copy running config to startup config. Enter, enter, enter. Okay, enter to confirm. Okay, and another enter. So you can use the terminal. And remember, R1 is connected to PCA. Okay, PCA desktop terminal. Okay, would you like to enter initial configuration dialog? No. Enter, enter. Enable configure terminal on global configuration mode. Copy this and paste. Copy and paste. Okay, very good. Copy running config, startup config. Okay. Now, for R2, remember R2 is connected, the console of R2 is connected to PCB. Click on PCB, desktop terminal. Okay. Would you like to enter initial configuration dialog? No. Enter, enter. Enable configure terminal. Okay, and change here the host name is the only one difference, should be R2 according the addressing table R2. Okay, hostname R2 and the same configurations. Copy, paste. Okay, hostname R2, copy, and very nice. Configure basic settings for each switch. Okay, device name, DNS lookup, privilege encrypted password, console password, BTY password, encrypt the plaintext passwords, banner, and save the running configuration to startup configurations. Okay, the same configuration for switches, hostname, domain, the privilege encrypted password, the console password, BTY password, encryption, banner, copy, running config to startup config is the same. So change fields, change the console. So remember, PCA is connected to R1, the console of R1. On S1, right-click, inspect rear, and drag the console cable from R1 to S1. And now you have this connection from PCA port RS 232 to console port on S1. So go to PCA. This is PCA. Close the terminal, open again. Okay. Now this is the switch command line interface. Enter enable configure terminal. On global configuration mode, okay, change this to S1. S1 and the same configurations. Right click to paste. Okay, very nice. Now remember, PCB is connected to the console of R2. So right click on S2, inspect rear, and drag the console cable from R2 to S2. Now you have this connection from PCB port RS232 to console port on S2. So go to PCB, close terminal, open again. Okay. Okay, this is the command line interface on S2. Enable configure terminal. Global configuration mode. Change the host name to S2 and copy this. The same configuration. Very nice. Configure VLANs on the switches. Create the VLANs on both switches. Create and name the required VLANs on each switch from the VLAN table. Okay, this is the addressing table, but down here is the VLAN table. Okay, I will do it on Notepad again. Okay, I will use Notepad and VLAN 20 management field operations for the sales. 999 parking lot and 1000 is native. Okay, but remember, be careful with the names. Should be case sensitive. VLAN 20 name management. VLAN 30 name operations. VLAN 40 name sales. VLAN 999 name parking lot. VLAN 1000 name native exit. Okay, be careful with these names. Okay, review management, operations, sales, parking. Okay, lot. Okay, sensitive native. Copy this to S1 and S2. Go to PCA. PCA. Okay, this is S1. Enter configure terminal. Global configuration mode paste. Okay, very good. Go to PCB that is connected to S2. Switch S2. Enter configure terminal. Global configuration mode paste. Very nice. Configure the management interface and default gateway on each switch using the IP address information in the addressing table. Okay, these are the configurations. Okay, on S1, go to S1, go to PCA. Okay, on interface VLAN 20. Okay, interface VLAN 20. Interface VLAN 20. IP address 10.20.02.285.285.285.0. Enter. Okay, and no shutdown is not necessary because interface VLAN 20 changed state to up. So exit IP default dash gateway 10.20.01. Okay, go to S2. Okay, interface VLAN 20, IP address 10.20.03.285.285.255.0. Okay, exit IP default dash gateway 10.20.01. Okay, very good. Assign all unused ports on the switch to the parking lot VLAN. Okay, the unused ports on S1. Okay, go to S1, this PCA. Ports in use are on facet 1, 5, and 6, so the range is interface range. Facet 2 to 4, comma. Facet 7 to 24, and gigabit 0, 1, and 2. Okay, 1 in use, 2 to 4, 5 and 6 in use, 7 to 24, and gigabit 0, 1, and 2. Okay, you can verify the VLAN table. 24724 gigabit 0, 1, and 2. 24724 gigabit 0, 1, and 2. Enter. Configure them for static access mode. Switch port mode access. And administratively deactivate them. But before this, assign unused ports to the parking lot VLAN. So parking lot VLAN is VLAN 999. Switch port access VLAN 999. And then administratively deactivate them. Shut down. Enter. Exit. Don't forget S2. Go to PCB. Ports in use are facet 1, facet 5, facet 18. Interface range. Facet 2 to 4, comma. Facet 6 to 17, comma. Facet 19 to 24, and gigabit 0, 1, and 2. Okay, 1 in use, 2 to 4, 5 in use, 6 to 17, 18 in use, 19 to 24, and gigabit 0, 1, and 2. You can verify here 2, 4, 6, 17, 19, 24, gigabit 0, 1, and 2. 2, 4, 6, 17, 19, 24, gigabit 0, 1, and 2. Okay. Switch port mode access. Switch port access VLAN 999. Okay, parking lot VLAN and shut down. Enter. Exit. Assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLAN. Specify it in the VLAN table and configure them for static access modes. Okay, for example here on S1 facet 6 to VLAN 30. On S1 facet 6 VLAN 30 for PCA. Okay, go to S1 PCA. Interface facet 6. Switch port mode access. Switch port access VLAN 30. Okay, operations for PCA. And now for S2 facet 5 to VLAN 20. S2 facet 5 VLAN 20 for router R2. Go to PCB, that is the command line interface of S2. Interface facet 5. Okay. Switch port mode access, switch port access VLAN 20. Okay. And facet 18 to VLAN 40. Facet 18 on S2 to VLAN 40 for PCB. 18, switch port mode access, VLAN 40, exit. Okay, very good. Show VLAN brief to verify. For example, on PCB and show VLAN brief. You can see 20 to facet 5, 40 to 18, unused ports to parking lot 999, and facet 1 will be configured as trunk on the next step. Okay, for now is on VLAN 1. So configure trunking. Configure trunking. Manually configure trunking on interface facet 1. Change the switch port mode on interface facet 1 to force trunking. Make sure to do this on both switches. Okay, go to switch S1 PCA. Okay, S1 facet 1 switch port mode trunk. Okay, switch port mode trunk. Set the native VLAN to 1000 on both switches. Okay, remember the native VLAN is 1000. Okay, so switch port trunk native VLAN 1000. Okay, 3 zeros 1000. Okay, and wait a moment, and you will look at this native VLAN mismatch. You may see error messages temporarily while the two interfaces are configured for different native VLANs. Facethernet 1 on S1 is using now VLAN 1000 as the native, but Facethernet 1 on S2 is still using the VLAN number 1 as the native. So they are different. So that's why you will see these messages, VLAN mismatch. Okay, and specify that VLANs 10, 20, 30, and 1000 are allowed to cross the trunk. Okay, but this is incorrect because we are not using VLAN 10. VLAN table specifies VLAN 20, 30, 40, and 999 and 1000. 999 is for parking lot, is for unused ports. So you need to permit VLAN 20, 30, 40, and 1000 on the trunk. Okay, and this is incorrect. This should be specify VLANs 20, 30, 40, and 1000. 20, 30, 40, and 1000 are allowed to cross the trunk. Okay, enter switch port trunk allow VLAN 20, 30, 40, and 1000. Okay. This is very good. Okay. Okay, and the same configuration on NS2. Go to PCB, enter S2, configure terminal interface for satellite 1, switch port mode trunk, switch port trunk, native VLAN 1000. Okay, be careful, is 1000. And now you can see port consistency restored, very nice. Switch port trunk allow with VLAN allowed VLAN 20, 30, 40, and 1000. Okay, very nice. This is very good. 20, 30, 40, and 1000. And show interface strong to verify. For example, on S2, and show interface strong. Port FACET1. Mode on. Manually configured encapsulation AO2.1Q. Status trunking native VLAN 1000. Allowed VLANs 20, 30, 40, and 1000. Very nice. Okay, and manually configure S1's trunk interface FACET 5. Configure S1's interface FACET 5 with the same trunk parameters as FACET 1. Okay, this interface FACET 1 configure as trunk. Okay, go to S1 that is connected to PCA. Okay, S1 FACET 5 switch port mode trunk, switch port trunk native VLAN 1000, and allowed VLANs. Okay, exit. Save the running configuration to startup configuration and copy running config to startup config. Enter. Go to PCB. Copy running config to startup config. Enter. Configure routing. Configure Inter-VLAN routing on R1. Activate interface gigabit 001 on the router. Okay, this interface on R1 gigabit 001, the connection to switch S1, but I will do this at the end. Okay, now configure sub interfaces for each VLAN as specified in the addressing table. Okay, and start with this sub interface gigabit 001.20. Okay, but to configure R1, change the console from S1 to R1. Right click on S1, inspect rear, and drag the console cable from S1 to R1. Okay, and go to PCA, close the terminal, open again. Okay, you are on the router, and the console password is Cisco. The enable password is class, configure terminal. Now you are on global configuration mode and configure gigabit 001.20. This sub interface gigabit 001.20. Enter. Okay, all sub interfaces use AO2.1Q encapsulation. Encapsulation.1Q. Okay, and use the VLAN 20. Okay, VLAN 20. VLAN 20 is management. Okay, VLAN 20, sub interface 20, and network 20. Okay, enter. Okay, and set the IP address. IP address 10.20.01, 255.255.255.0. And don't forget, include a description. Okay, you can use the name of the VLAN as the description. You can use any description, but I will use the name of the VLAN management. Okay, now the next sub interface is 30. The description is for 30. I will use the name operations, the name of the VLAN operations. Now for the next 40, network 1040, descriptions, sales, okay, sales, enter, and the next sub interface 1000, encapsulation 1000, we specify is native, okay, remember 1000 is the native, okay, enter, ensure the sub interface for the native VLAN does not have an IP address, okay, no IP address for sub interface 1000. Okay, so description, native, enter, and now activate interface gigabit 001. Go to gigabit 001 and no shutdown. Okay, very good. Configure interface gigabit 000. Okay, should be gigabit 000. This interface. Configure interface gigabit 000 on R1. Okay, on R1. Interface gigabit 000. IP address 172.16.11.285.285.285.0. No shutdown. Okay, very nice. This is the connection to the server. Gigabit 000 is the connection to the server. Show IP interface brief to verify, and show IP interface brief. Okay, gigabit 000 app, gigabit 001 app, sub interfaces app. Configure R2 interface gigabit 001. Okay, R2, this interface gigabit 001, the connection to the switch S2. Use the addressing table. Okay, and this configuration, and change the console port from S2 to R2. Inspect rear, drag the console cable from S2 to R2. Okay. Click here on PCB, because now PCB is connected to the console of R2. Close the terminal, open again. Okay. Enter console password is Cisco, enable password is class, configure terminal, R2 global configuration mode. Configure this interface gigabit 001, IP address 10.20.04.285.285.285.0. No shutdown. Enter. And configure a default route with the next hop 10.20.01. Okay, this is like the default gateway. Okay, exit on global configuration mode, a default route, IP route, the default route, and the next hop 10.20.01. 10.20.01. Very good. Okay, on R2. Now configure remote access. Configure all network devices for basic SSH support. Okay, I will do this on Notepad because this will be useful for routers and switches, because instruction says configure all network devices. Okay, this includes routers and switches. Create a local user SSH admin with this password, and the password is an encrypted password. Okay, on Notepad, enter. username SSH admin, case sensitive, the encrypted password, so use the secret command, and this password $Cisco 123 and exclamation. Enter ccna-lab.com is the domain name. IP domain name ccna-lab.com. Enter. Generate crypto keys using a 1024-bit modulus. Okay, crypto key generate RSA general keys modulus 1024. Configure the first 5 VTY lines on each device to support SSH connections. Okay, and the first 5 are line VTY from 0 to 4. You have the first 5. Okay, but I will use all lines from 0 to 15 because this will be required to get the 100%. So first 5 is a very good configuration to configure the first 5 VTY lines to support SSH connections. But at the end, you will not be able to get 100%. So use all lines from 0 to 15. Okay, and support SSH connections only. Transport input SSH. And authenticate to the local user database to use this username and password. Okay, login local exit. Okay, verify username SSH admin case sensitive secret password. This is the password, be careful. Domain name, be careful. The crypto key, very nice. And copy this. Go to PCA. You are on R1. Configure terminal. On global configuration mode, paste. Okay, very good. This is the generation of crypto key. Go to PCB. R2 global configuration mode, paste. Okay, very nice. On the switches, don't forget that. Right click on S1, inspect rear, drag the console from R1 to S1. On S2, right click, inspect rear, drag the console from R2 to S2. Now access PCA, close terminal, open again. Enter console password is Cisco. Enable class, configure terminal, paste. Okay, SSH configuration. Go to PCB, close terminal, open again. Okay, sorry, okay. Enter Cisco. Enable class, configure terminal, paste. Okay, very good. Verify connectivity. But now configure PC hosts according to the addressing table. Okay, this is the PCA configuration. So go to PCA, close this, IP configuration, 10 0D010. Okay, 285, 285, 285, 0, 10 0D01. Okay, and go to PCB, close terminal, open IP configuration, configure this. Then 4D010, 285, 285, 285, 0, 10 4D01. Okay, and the server A desktop IP configuration already configured. Okay, and use this table from PCA ping 104010. 104010 is PCB, so ping from PCA to PCB. Go to PCA, close this, open command prompt, ping to PCB 104010. Success from PCA ping 102001. 102001 is R1. 102001 is R1. Success from PCB ping 100010. 100010 is PCA. Okay, from PCB ping PCA. Go to PCB, close this, command prompt, ping to 100010. Success from PCB ping to router R1 102001. 102001. Success from PCB ping 172.16.11. Another interface on R1 172.16.11. Okay, from PCB ping 172.16.11. Success from PCB use HTTPS to access the server 172.16.12. The server is 172.16.12. Okay, go to web browser. Okay, from PCB https ://172.16.12 172.16.12 using HTTPS. Enter success. From PCA access the server using HTTPS PCA https ://172.16.12. Success from PCB SSH to 10.20.04. 10.20.04 is R2. Okay, from PCB go to PCB, close the web browser, open the Telnet SSH client, use SSH 10.20.04. Okay, the IP address of R2, the username, remember, is this SSH admin case sensitive, and use this password SSH admin connect password $Cisco123 exclamation. Very nice. R2 exit. No. And from PCB access SSH of R1. Okay, again go to PCB 172.16.11 SSH admin. Okay, SSH admin connect $Cisco123 exclamation. Now you are on R1. Very nice. Exit. No. And now configure and verify extended access control list. Okay, when basic connectivity is verified, the company requires the following security policies to be implemented. Okay, policy 1. The sales network is not allowed to SSH to the management network. Policy 2. The sales network is not allowed to access the server using any web protocol. Policy 3. The sales network is not allowed to send ICMP echo requests to the operations or management networks. Policy 4. The operations network is not allowed to send ICMP echo requests to the sales network. And look at this. Policy 1, Policy 2, and Policy 3 have the sales network as the source. Policy 1, sales network is the source. Policy 2, sales network is the source. And Policy 3, sales network is the source. And remember, sales network is VLAN 40 and is also network 40. So if sales network is the source for the three policies, you can use only one access list to implement these three policies. Okay, you can use only one access list. And also, this access list should be extended access control list. Okay, should be extended. And it's recommended to configure it's recommended to implement the extended access list on the source, close to the source. Okay, and will be implemented close to the sales network. Okay, and if this is the network of the sales network, should be implemented on gigabit 001.40 on this sub interface. The access list, the extended access list, should be implemented close to the source. So on gigabit 001.40. Okay, so you need to configure this on R1. Okay, go to R1. Change the console, inspect rear, drag the console from S1 to R1. Very nice. Go to PCA, terminal. Okay. Enter Cisco enable class, configure terminal. Okay. The sales network is not allowed to SSH to the management network. Okay. Select extended access control list. Is not named access list, is not named extended access list, is only extended access list. So use a number. Okay, we use a number. Access list 1 of 1. Okay, this is a number for extended access list and is not allowed. Okay, deny. SSH uses TCP protocol, deny TCP. The source is sales network. Is this sales is VLAN 40, so it's network 40. So use the network 1040.00 and the subnet mask wildcard or inverse. Okay, the destination is management network. Management is 20, so the network is 20. 10.20.00 wildcard and use SSH port equivalent to 22. Okay, the SSH port. Okay, enter. Okay, with other SSH is allowed. Okay, I will do this at the end of the access list. Okay, now policy 2. The sales network is not allowed to access server A using any web protocol, HTTP, HTTPS. Okay, the sales network is the source again. Access list 101 is the same access list, deny because it's not allowed. The source is the sales network, network 40. Sales network is the source, but the destination is server A. Server A is this IP 172.16.1.2. So you can specify the host 172.16.1.2. Okay, and the web protocol HTTP is port 80. Okay, and you can use this host keyword, or you can use the following wildcard 000. Both are valid. Both are the same. Okay. Port 80 for HTTP. Okay, the source is sales network, is not allowed, deny, protocol TCP. The destination is the server, only the host, not the network, only the host. Port 80 for HTTP. And don't forget HTTPS 443. Enter. Okay, the same entry, but change the port for HTTPS. The sales network again is not allowed to send ICMP echo request. Okay, so deny ICMP. Okay, ICMP protocol, sales network not allowed. Deny, not allowed, deny ICMP protocol. Source, the sales network. Destination, operations. And remember, operations is VLAN 30, network 30. Then, okay, 10.30.00 wildcard, and is echo request. Echo. Okay. Deny ICMP protocol, sales network, operations network, echo request, enter. Also, sales network is not allowed to send ICMP echo requests to management networks. And remember, management is VLAN 20, network 20. Okay, 20. So only change this. Deny ICMP, sales network the source, management network the destination, echo request, enter. And now look at this. Other SSH is allowed, other web traffic is allowed, ICMP echo request to other destinations allowed. So you can use access list 101 permit IP from any to any to permit any other traffic. Okay, enter. Okay, and an extended access list is recommended to be implemented close to the source. So the source is always the sales network, so should be implemented close to the source on sub-interface gigabit 001.40, gigabit 001.40. Okay, IP access group 101, the number of the extended access list, and is incoming traffic. Okay, incoming traffic. Okay, so it's incoming traffic because the traffic is trying to exit the VLAN to access another networks. Okay, incoming traffic. If you set outgoing traffic, the traffic will go to the internal VLAN. So use incoming traffic. The traffic will go to the another networks. Okay, enter, exit. And finally implement this. The operations network is not allowed to send ICMP echo requests to the sales network. Okay, the source is operations network. An operations network is placed on VLAN 30, and extended access list should be implemented or is recommended to be implemented close to the source. And operations network is VLAN 30, VLAN 30 and network 30. So the source is the interface gigabit 001.30, and if will be implemented close to the source, will be implemented on R1. R1. Okay, so again, configure on R1. You can use access dash list 102 and not allow it, deny, ICMP echo request, ICMP protocol. Operations network is the source, is 30, 10, 30, 00, the wildcard. The destination is sales network. Sales network is 40, network 40. Okay, 10, 40, 00. Wildcard is echo request, so it's echo. Very good. Okay, enter. And ICMP echo requests to other destinations are allowed. So use this access list 102, the same access list permit IP from any to any. And implement close to the source. The source is network 30, close to the source is sub-interface 30, IP access group 102, incoming traffic, exit. Very good. Okay, and now verify that security policies are being enforced by the deployed access list. Run the following test. The expected results are shown in the table. Okay, on the previous test, all were success. But now some results will fail. Okay, some results will fail. Okay, because the access lists are implemented. Okay, and now from PCA ping PCP 1040.0.10. Okay, 1040.0.10 is PCB. Okay, go to PCA close terminal, open command prompt, ping to 1040.010. Destination host unreachable. Okay, fail. Very good. From PCA ping 1020.01 is router R1 1020.01. Success. Success. Very good. From PCB ping PCA. Go to PCB, close the SSH client, command prompt. From PCB ping 1030.010, that is PCA. Destination host unreachable. Fail. This is very good. From PCB ping 1020.01 is router R1 1020.01. Destination host unreachable. Fail. So this is very good. From PCB ping 172.16.11, another interface on router R1 172.16.11. Success. Success. Very good. From PCB web browser HTTPS to the server, close command prompt, web browser https://172.16.12, enter. Okay, wait a moment, please. Request timeout. Fail. Very good. From PCA, access the server using HTTPS. From PCA, close the command prompt, open web browser, https://172.16.12, enter. Success. Okay, success, very nice. From PCB, access SSH to the router R2. Okay, from PCB, go to PCB, close web browser, open SSH client, SSH hostname or IP address. It's 1020.04. Username is SSH admin, case sensitive, connect. Wait a moment, please, and the current session has closed. Okay, no, fail. So this is very good. From PCB SSH to the router R1, from PCB 172.16.11, SSH admin, connect, password, $Cisco123 exclamation. Okay, again, $Cisco123 exclamation. Very nice. R1. Exit. No. Success. Very good. Okay, completion 93%. Check results. Assessment items. Green, green, green. All in green. Very good. Connectivity test. Correct, 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 correct. Very nice. Congratulations on completing this activity. Okay, and close. But the completion is 93%. And don't worry about this. All is completed. Thank you very much.